Hi, this is Sarah McLeod, your host for Proven Cures, and I am making this video today. Well, first of all, excuse my appearance, I am still on vacation, but I really wanted to make this video before I run off and start my evening at the Apollo Theater tonight. But I'm really making this video in honor of this month, which is National Diabetes Awareness Month in the United States. And what I came to realize is that I had done a three-part series for type 2 insulin dependent diabetics, but I hadn't done anything for the type 1 diabetics, and I hadn't done any research for them rather. And it was really hard to find something that would be truly helpful for these kind of diabetics, simply because their bodies don't make sufficient insulin. So it took me longer than a day actually to find some information, but luckily I was able to find the information. So first let me explain, because I make these videos not just for the medical community and the scientific community, but for regular everyday people who may not understand the pathology of what is going on with their bodies. If they're sick, they just know that they're sick and they have to take something, but they may not truly understand what's going on. So first let me explain the difference between type 1 and type 2 diabetics. So with type 2 diabetics, their bodies do create insulin, but they are simultaneously resistant to the insulin, so they don't get the benefit from the insulin. With type 1 diabetics, now their bodies don't create sufficient insulin at all, so they are beholden to artificial insulin just in order to be able to utilize the sugar in their bodies, in their bloodstreams, in order to stay alive and be healthy. Okay, so now I did somewhat explain the role of insulin just now. However, I would like to explain it in greater depth. So now, when a healthy person eats, the brain signals cells in the pancreas to release insulin into the bloodstream, right? So once insulin is in the bloodstream, it attaches itself and it also signals cells in the fat tissue, the muscles, and the liver to take glucose, which is just a fancy word for sugar, from the bloodstream and use it for energy. So now imagine if your body didn't make enough insulin, as is the case with type 1 diabetics. They always have this excess sugar roaming around in their bloodstreams. And so what therapy other than taking artificial insulin could possibly be available to save their lives? This has been baffling the scientific community for years, and in 1988, a researcher by the name of David James found a distinct protein inside of fat tissue and skeletal and cardiac muscle that is regulated by insulin and is responsible for the transport of sugar from the bloodstream, and it is called GLUT4, or glucose transporter protein type 4. Now, this key discovery of GLUT4 gave other researchers a straw to grasp onto, meaning that they figured that if they could find a substance that can activate this transporter of glucose, then they can control diet with insulin. So the results of next shares just that information with you. It is called Biomolecular Characterization of Putative Antidiabetic Herbal Extracts. It was published 2 years ago, January of 2016, in a journal called PLOS 1, that's PLOS 1. And the study was conducted by Austrian researchers. I always like to give the specific names of the researchers because I like to give credit where credit is due. Give me 1 second so I can get those names for you. Yeah, the researchers who conducted this study and published the results are Verena Stadelbauer, Renate Hazel-Grubler, Peter Lanzerstorfer, Brigitte Plockberger, Daniela Borgman, Jaroslaw Jasak, Stephen Winkler, Klaus Schroeder, Otmar Hoglinger, and Julian Weghuber. That also allows you to look up the study for yourself, should you choose to verify any information that I share here. So, activation of the glucose transporter protein GLUT4 was determined by a process during a study called Total Internal Reflection Fluorescence Microscopy, or TIRF microscopy. So if you hear me use that term later on during this discussion, you'll know what I'm referring to. It's basically the process that the researchers used to determine if what they're studying was actually working, if it was activating that protein to move glucose from the bloodstream into the cell. Okay, so during a study, insulin-sensitive cloned Chinese hamster ovarian cells and fat cells were respectively incubated with a solution of 50 milligrams per liter of Purslane extract. So you may want to write this down at this point. That's Purslane. That is Purslane. And it was compared, those cells that were incubated with Purslane were compared to another set of insulin-sensitive hamster ovarian cells and fat cells that were respectively incubated with 100 nanomoles of insulin. So we have our experimental group, which was a set of cells that were incubated with Purslane, and then we have our control group, which was our set of cells incubated with actual insulin. Okay, so TIRF microscopy showed that the experimental group of cells incubated with Purslane actually did induce GLUT4 translocation, accompanied also by an increase of intracellular glucose concentrations, specifically in the plasma membranes of cells. So in simpler terms, when compared with 100 nanomoles of insulin, 50 milligrams of Purslane mimic the effects of insulin in insulin-sensitive cells. So this is very, very promising. Now, if you've never heard of Purslane, prior to my conducting this research, I hadn't heard of it either. It is actually a leaf vegetable that is eaten in many countries, and it has been reported to improve serum triglyceride levels and blood pressure in persons suffering from type 2 diabetes mellitus. Purslane has also been reported to contain high levels of omega-3 fatty acids, vitamins, and phytochemicals such as betalain pigments. A Purslane herb extract termed Portusana, that's Portusana, was actually used for this specific study and is promoted as an intestinal, it has dual promotion as both reducing intestinal glucose absorption, right? Reducing the absorption of glucose within the intestine, while simultaneously increasing insulin sensitivity and cellular glucose uptake, which was what was proven by the study. So now you must be thinking, this sounds really promising, that there's actually a leaf vegetable that can mimic insulin in the body of type 1 diabetics, right? That's really awesome. But you must be thinking, 100 nanomoles of insulin versus 50 milligrams of Purslane. How do I convert that? How would I know how much Purslane to even take or eat in order to get the same benefit? I was wondering the same thing, and I did a whole bunch of research trying to figure out what to tell you, like how to relate cellular research to actual human subject use, And what I found was another website called alkalinevalley.com. And on that website, they mentioned an unnamed study where researchers actually gave human subjects with high blood sugars 180 milligrams of Purslane every day for 5 weeks. And what the scientists found was that participants who started out with blood sugar levels of 200 and below were able to lower their blood sugar after 2 to 3 weeks, and those who started out with levels over 200 were able to lower their levels after 4 to 5 weeks. So that gives you a pretty good idea. I also did an Amazon search for Purslane itself, and I found it being sold in milligrams of 440, which is pretty high. But I was thinking, I myself would start with just one, because I'm all about preventative medicine, and I look at my weight and I look at my age and I think about these things. And also I have diabetes on both sides of my family, so it's something that worries me. And I know that as you get older, it gets more and more difficult to control your blood sugars, especially if you're not particularly active all the time, which I am not. Now that I'm on vacation, I am, but I know that once I go back home, I'll probably become way more sedentary and that kind of thing. So as a quick recap of Purslane, it increases glucose uptake into the cells. That's the first benefit. It slows down the process of transporting glucose from the intestines into the bloodstream. It lowers the hemoglobin A1C. And it enhances insulin sensitivity, which is particularly beneficial for people with type 2 diabetes. So I hope you found this helpful. Please like, share, subscribe to Proven Cures. Make sure you hit that notification bell so that you will get notified every time I do a new video. And once again, this is National Diabetes Awareness Month. If you have diabetes, God bless you. I hope you find benefit in supplementing your diet with Purslane. I am definitely going to give it a try. And please stay healthy and be blessed, and subscribe to my channel. Thanks for watching. Bye.